RAM stands for Random Access Memory, and the name is actually descriptive. It's memory that can be accessed in any order, instantly, rather than having to read through it sequentially. Here's the core idea. Your computer has two main types of storage. There's long-term storage, your SSD or hard drive, where everything lives permanently. Your files, your apps, your operating system. It survives when you turn the power off. And then there's RAM, short-term working memory. Fast, temporary, and it disappears completely when you power down. When you open an app, your computer copies it from storage into RAM. Why? Because RAM is dramatically faster than even the fastest SSD. Your processor can read from RAM in nanoseconds. Reading from an SSD takes microseconds, 1,000 times slower. And a hard drive is even slower than that. RAM is your computer's workspace. Everything you're actively working with right now, the browser tab you're reading, the document you're editing, the game you're playing, it all lives in RAM while it's in use. Here's where it gets practical. RAM has a fixed capacity, 8 gigabytes, 16, 32, whatever your device has. When you fill it up, your computer has a problem. On a PC or Mac, the operating system deals with this by using a trick called virtual memory, or swap. It takes the stuff in RAM that hasn't been used recently and writes it back to your SSD to free up space. Then, when you need that stuff again, it reads it back from the SSD into RAM. This is called swapping or paging, and you feel it immediately. That moment when you switch to an app and it freezes for a second before catching up, that's your computer frantically reading data back from storage because it ran out of RAM. On phones, it's slightly different. iOS and Android handle memory pressure by killing background apps entirely rather than swapping to storage. That's why you switch back to an app you were using an hour ago and it has to reload from scratch. It was evicted from RAM to make room for whatever you were doing more recently. More RAM means more apps can stay alive in the background. Less reloading. Smoother switching. This is the question everyone actually wants answered. And the honest answer is, it depends on what you do. But let me give you some real numbers. For a Windows PC in 2025, 8 gigabytes is the minimum. It'll work, but you'll feel the limits if you have more than a few browser tabs open alongside other apps. 16 gigabytes is the sweet spot for most people. Enough headroom for normal multitasking without paying for capacity you'll never use. 32 gigabytes starts making sense if you're editing video, working with large data sets, or running virtual machines. For Macs, Apple's unified memory architecture is more efficient than traditional RAM, so 8 gigabytes goes further than it would on Windows. But 16 is still a better starting point if you can afford it. For phones, 8 gigabytes is comfortable for most people. 12 or more starts to matter if you're a heavy multitasker or you keep a lot of apps open simultaneously. The one thing I'd push back on is the idea that more RAM always makes things faster. RAM doesn't make your processor faster. It doesn't improve your GPU. It just determines how much you can have open at once before things start slowing down. If you're not hitting your RAM limit, adding more won't change anything you notice. Rather than guessing, here's how to actually check whether RAM is your bottleneck. On Windows, open Task Manager and click the Performance tab. Look at your memory usage while you're doing whatever it is you normally do. If it's consistently above 80 or 90%, you're RAM constrained and more would help. If it's sitting at 50%, adding more RAM will do nothing for you. On a Mac, open Activity Monitor and look at memory pressure. Green means you're fine. Yellow means you're starting to push it. Red means you're regularly hitting your limit, and an upgrade would make a real difference. On a phone, there's no direct equivalent. But the symptom is simple. If apps constantly have to reload when you switch back to them, you're running out of RAM. If they pick up right where you left off, you have enough. The upgrade is only worth it if you're actually hitting the limit. Check first, then decide. One thing worth knowing is that RAM is changing in ways that matter. Apple's unified memory, used in every Mac since the M1, pools RAM so that the CPU, GPU, and other chips all share the same high-bandwidth memory. Traditional PCs have separate pools of RAM for the CPU and VRAM for the GPU. Apple's approach is more efficient and is part of why M-series Macs perform so well with relatively modest memory numbers. On phones, LPDDR5X, the latest mobile RAM standard, is significantly faster and more power efficient than what was in phones just a few years ago. Faster RAM means the processor spends less time waiting for data, which improves real-world performance beyond just having more of it. And AI is starting to push RAM requirements up. Running large language models locally, AI photo editing, real-time AI features, these are all memory hungry. 16 gigabytes is becoming the new 8 gigabytes as AI workloads become part of everyday computing.